on, we're going to be talking about binomial theorem. And why do we use binomial theorem when talking about binomial expansion? It's just a very convenient and efficient way of expanding a binomial, especially as the exponents do get bigger. Just in a word, it's just more practical. And it's very practical versus traditional expansion and Pascal's triangle. Those are effective, but they're just more time consuming, as well as they leave more room for error. So to move on, we're just going to look at the formula. And so the formula does look a bit complicated, but we're going to work through it. And so we just have here like where the different components are coming from the formula. So we have a plus b raised to the n power. And then this is representative of the first term. And then this is representative of the nth term, or whatever term you're looking for. And so just to kind of explain it, we're just going to start off with like a quick example. So we have the binomial 3x plus 8 raised to the 8th power. And so we're going to look for its first term and its fifth term. And so here we're looking for the first term. And since we're looking for the first term, our r value is always 1 less than the term we're looking for. So r is equal to 0. Our a is going to be equal to 3x. Our b is going to be equal to 2. And then our n is going to be equal to 8. And so we're going to use that information and plug it into the formula here that we had up here. And when we do that, we just kind of calculate it. The only new part is this 8 choose 0 part. And the way that we can calculate that is that it does have a coefficient formula. That's what it's called. And so here it is like applied to this specifically. But in general, this is representative of your n value. This is your r, and then this is your n minus r. And then we can do this on our calculator by going to math. And then in math, we're going to go to probability, and then we're going to go to n choose r, and then we're going to put 8, and then here we're going to put 0, and then we're going to get 1. And so overall, we just calculate, and we should get that it's 6,561 times x to the 8th power. And we're also going to do this for our fifth term. Again, the fifth term, since we're looking for the fifth term, we're going to do that r is equal to 4, since we're looking for the number that's less than the term we're looking for. We're going to use the same variables, and again with the 8 choose 4, you can choose to use your calculator for that, as we did in the example in the part before. And when we calculate, we should get that it's equal to 90,720 times x to the 4th power. And just like an interesting pattern to notice about this is that the exponents, like the different parts that have the exponents, do add up to like the main exponent up here, the n exponent. And we see this through, so right here, this is 8, and then this is 0, so 8 plus 0 is equal to 8. And then over here, we have 8 minus 4, which is just 4, and then 4 here, and then 4 plus 4 is equal to 8. So the exponents add up to 8. The second example is going to be similar to the first one, and we're going to be looking at 4x plus 3 raised to the 12th power, and we're going to try to find the second term and the last term. And so to find the second term, we're first going to identify that a in the formula is going to be equal to 4x, and then b is equal to 3, and then our n is 12, and since we're looking for the second term, our r is going to be equal to 1. We're going to plug that all into the formula. Again, the 12 choose 1, we can use a calculator for that, and then the rest we can also use a calculator as well. When we calculate that, we get that that's the coefficient of x to the 11th raised to the 11th power is going to be 150,994,944. We're going to do a similar thing for the last term. So in total, there are 13 terms. We're looking for one less than that term. So r is going to be equal to 12. N is going to be equal to 12 still. We're going to plug in the information we know into the formula, and then we're going to calculate, and we're going to get that it's equal to 531,441. And this makes sense because here the exponent would be equal to 0, and it would go to like x to the power of 0, which would just be 1. So it makes sense that there's no variable there. Or, yeah. And so now we're going to do our third example. And the third example is going to be a little bit more complicated, but it will make sense in the end. So we have 5x plus y is raised to the 15th power, and we're trying to find the coefficient of x raised to the 6th power. So the first thing we're going to do is just identify what we know. We know that a is equal to 5x, b is equal to 5, and then our n is equal to 15. So we're just going to plug in what we know into the formula. So here we have the original formula, and then here we have what we know in the formula. So basically the only thing we're missing is the r. To start off, we're just going to look at this part right here, n minus r, or here it's 15 minus r, because what we're looking for is the when the x has an exponent of 6. And so what we're basically going to do is set that equal to 6, since that's what we're looking for. We do know n, so we're going to do 15 minus r equals 6, and then we're going to just solve for r, and we get r is equal to 9. Now that we know what it's equal to, we're just going to substitute that into our formula, and we're going to get 15 choose 9 times 5x raised to the 6th power times y raised to the 9th power. Once we do that, we're going to calculate, and we're going to get that our coefficient for x raised to the 6th power is 78,203,125. And then to finish off, you guys are just going to do this problem here, and it's 2y raised to the 2nd power plus 4x raised to the 3rd power, and then that's all raised to the 5th power, and you're trying to find the coefficient of x raised to the 6th power, y raised to the 6th power. And here's the answer for it, and then this is like the possible working that you could have done to figure that out. Thank you for watching. Hope you enjoyed.